Nisha ma'am, mute your presentation ma'am. Don't present your screen. Sneha ma'am, mute your video.
Hello.
Yeah ma'am.
Yes.
Sneha ma'am, please mute your video.
आता इकडनं कशाला येते मला लांब पडेल ना किती
Sneha ma'am, mute your audio and video.
Voice is not clear. Voice is not clear. Voice is not clear. Voice is not clear. Voice is not clear.
Intan ma'am, we'll start the meeting within 5 minutes.
Okay.
Okay, fine. Dear professors, please mute your audio and video. Dear participants, please mute your audio and video.
Or loose. Yeah. Kalaran. One the
Sunita ma'am, shall we start the program?
Yes, Pari.
Yeah, ma'am. நான் இப்ப என்ன சொல்லணும் ஒன்னும் சொல்ல தேவையில்ல.
Good afternoon, dear participants. This is Dr. Geeta, Associate Professor and Head, Department of Mathematics, Banariaman Institute of Technology, Satyamangalam, Erode District, Tamil Nadu, India. I have been associated with the institute for the past 23 years. The Banariaman Institute of Technology, Satyamangalam, was established by the Banariaman Group in 1996 and is affiliated to Anna University, Chennai. I heartily welcome you all on behalf of Banariaman Institute of Technology, Satyamangalam, for our International Faculty Development Program on Avant-garde Trends in Mathematics from 17/6/2020 to 23/6/2020. The idea of putting the foundation of this faculty development program is so inspiring. What was once planted as a sapling is now all grown into a large tree. Here I can see a blend of extraordinary members of faculty from various states who have made this day arrive. They have come to us from each and every corner of the world. This faculty development program aims at equipping teachers with skills and knowledge that are essential for inculcating the entrepreneurial values in students and guiding and motivating their progress towards their career. In addition, engineers, scientists, and mathematicians want to experience the sheer joy of formulating and solving mathematical problems. Taking an afternoon further, and to begin with the function, I, on the behalf of everyone present here, heartily welcome the resource person of today's faculty development program, Dr. Intan, Associate Professor, Algebra Research Division, Faculty of Mathematics and Natural Sciences, Institute Technology, Bandung, Indonesia. She pursued her doctoral degree from University of Picardy, France, master's degree from Institute Technology, Bandung, Indonesia. Head of master program and doctoral program in mathematics, Institute Technology, Bandung, Indonesia. She has been held with various scientific membership as Vice President of Southeast Asian Mathematical Society during the year 2018 to 2021, President of Indonesia Mathematical Society during the year 2016 to 2018, and Head of Indonesian Algebra Society during the year 2011-2018, Secretary of Southeast Asian Mathematical Society 2014 to 2015. And she has been the member of Indonesian Young Researcher Forum, member of European Mathematical Society, as well member of American Mathematical Society. And she has also been awarded with an award as Prex Maharashundam from the Association Franco-Indonesia for Development of Science during the year 2004. And also Satya Lenkana Karya Sapta, 10 years from the Indonesia government, August 2012. And she has also been awarded with the Best Paper Award during the year 2016 and 2017 in the international conference. And she has also been the reviewer and editorial board member for quite a number of journals. I am especially thankful to her as when we approached her and requested her to grace this afternoon as a resource person, Dr. Intan accepted our request and readily agreed when she looked at today's event and its program. I welcome you, madam. I take great pride in welcoming all the attendees of the International Faculty Development Program on Avant-garde Trends in Mathematics being organized by the Department of Mathematics, Banariaman Institute of Technology. Holding such a faculty development program at a relatively short span of time would not have been possible without the invaluable support of a management. So at this juncture, I would like to thank the management. I would also like to extend my warm welcome to the convener of this program, Dr. M. Parimala, and her team for their tremendous support to make this event happen today. Lastly and importantly, I would like to welcome all the members of the faculty from various states and my own state, and also the research students who are the integral part of this faculty development program. Once again, I welcome you all. Madam, it's your turn to take this platform and give your inputs to all the participants and enrich the knowledge. Thank you, ma'am.
Okay, good afternoon. Thank you for the invitation. Let me start sharing my screen. Okay, can you see my screen? Is it clear?
No,
No,
ma'am.
ma'am. No.
Hello?
Yes. Now it has been presented.
Okay. So thank you very much once again for the chance to present, to share about this cryptocurrency and Bitcoin. I am Intan Muchtadi-Alamsyah from the Algebra Research Group, Faculty of Mathematics and Natural Sciences, Institut Teknologi Bandung. And today I will share about cryptocurrency and Bitcoin. So let me first, what is Bitcoin? So cryptocurrency is a form of electronic money or
Ma'am,
virtual
please present the
currency.
screen, ma'am.
And
Yes,
Bitcoin is one of the biggest successful representation of the cryptocurrency. It is a software-based online payment system described by Satoshi Nakamoto in 2008 and introduced as open source software in 2009. And in this system, the payments are recorded in a public ledger using its own unit of account. And it is form of digital currency created and held electronically. It can be used to buy things electronically, and in that sense, it is no different than conventional dollars. It's commonly referred as cryptocurrency, and it can be divided into smaller units called Satoshi. So it is run by the Bitcoin protocol. It is based on mathematics, unlike the conventional currencies that had been based on fixed quantity of metal, gold, silver, or other currencies. It has several features that set it apart from currencies. It is decentralized, easy to set up, and it is fast. It is anonymous, completely transparent. Transaction fees are minuscule, and transactions are irreversible. So this is based on Bitcoin protocol. It's a peer-to-peer system, which means that there is no need for a third party. It is not controlled by central authority and being created by a community of people that anyone can join. So it is a fully decentralized monetary system. In theory, there is no authority or financial institution which can tinker with monetary policy, and in that sense, they value or revalue Bitcoin currency. So unlike the currency that we have, usually there is authority by the bank or another financial institution. In this Bitcoin, we don't have, there is no authority. Bitcoins are stored in wallet with digital credential for your Bitcoin holdings and allows you to access them. This wallet uses public key cryptography in which two keys, one public and one private, are generated. Public key can be thought as a number or name, and the private key is the ownership credential. It's like public key is like you are having your email address, but then the private key is like your password. And Bitcoin is transferred to the next owner when the next owner gives a public key and previous owner uses his private key to publish a record into system, announcing that the ownership has changed to the new public key. Bitcoin protocol stores detail of every single transaction that occur in the network in huge version of general ledger, which is called blockchain. Bitcoin doesn't charge fees for either national or international transfers. And this is not the first private money, nor the first digital currency, and not first currency based on cryptography, but it has been the first to rely on peer-to-peer network decentralization to avoid double spending. It protects against double spending by verifying each transaction added to the blockchain to ensure that the inputs for the transaction had not previously already been spent. So the Bitcoins are created by a mining process where the miners use special software to solve mathematics problems. And upon completing the task, they receive a certain amount of coins. They are created each time a user discovers new block, and software is creating new units until it reaches amount of 21 million units. And the rate of block creation is approximately over time 6 per hour with 50% reduction every 4 years. And in theory continues until 2140 when 21 million BTC have been issued. So one can obtain Bitcoins from mining by accepting them as means of payment, through trading, as a regular income, from interest payment, or from donation, gambling, getting tips, completing tasks on website, and so on. So this is the diagram how Bitcoin transaction work. So let's say Bob, an online merchant, decide to begin accepting Bitcoins as payment, and Alice, a buyer, has Bitcoins and want to purchase merchandise from Bob. So now Bob and Alice have both have Bitcoin wallets on their computers, but wallets actually are files that provide access to multiple Bitcoin address. An address is a string of letters and numbers, such like that, and each address has its own balance of Bitcoins. So Bob creates a new Bitcoin address for Alice to send her payment to. And then when submitting a payment, Alice tells her Bitcoin client that she'd like to transfer the purchase amount to Bob's address. Alice's wallet holds the private key for each of her address. The Bitcoin client signs her transaction request with the private key of the address she's transferring Bitcoin from. And then, so Alice uses a private key. Anyone on the network can now use the public key to verify the transaction. And Gary, Gart, and Glenn here are the Bitcoin miners. They are verifying the transaction. They compute the bundle of transaction of the past 10 minutes into new transaction blocks. And their computers are set up to calculate cryptographic hash function. So now this is an example of cryptographic hash function to transform a collection of data into an alphanumeric string with a fixed length called a hash value. And even a tiny change in the original data drastically changes the resulting hash value. And it is essentially impossible to predict which initial data set will create a specific hash value. And to create different hash value from some data, Bitcoin use nonce. A nonce is just a random number that's added to data prior to hashing. Changing the nonce result is in a widely different hash value. So each new hash value contains information about all previous Bitcoin transactions. From hash value, we add the nonce, and then we have this new hash value, we add nonce again, and then new hash value again, we add nonce again. And the mining computers calculate new hash values based on a combination of the previous hash value, the new transaction block, and a nonce. Cryptographic hash functions transform a collection of data into an alphanumeric string with a fixed length. And creating hashes is computationally trivial, but the Bitcoin systems require that the new hash value have a particular form. Specifically, it must start with a certain number of zeros. And the miners have no way to predict which nonce will produce a hash. will produce a hash value with the required number of leading zeros. So they forced to generate many hashes with different nonce until they happen upon one that works. Each block includes a coin-based transaction that pays out 50 Bitcoins to the winning miner. For example, in this case, Gary. A new address is created in Gary's wallet with a balance of new Bitcoins. And so Gary has verified the transaction, and as time goes on, Alice transfer to Bob gets buried beneath other more recent transaction. For anyone to modify the details, he would have to redo the work that Gary did because any changes require a completely different winning nonce, and then redo the work of all the subsequent miners. Such a feat is nearly impossible. So the transaction between Bob and Alice will be placed here, and then there will be a new transaction and so on. And so to retrace is not easy. So now Bitcoins use the digital signature to prove that the signature owner is the account owner. In other words, owner owns private key. Private key is used to create the signature, and public key is used to verify the signature. This allows anybody can verify digital signature if they have its public key or account address. Private key is a single unsigned 256-bit integer, needs to be secret. Owner of the private key can spend corresponding account Bitcoins, and the private key used to generate digital signature and public key. And this is an example of private key. Public key is obtained from elliptic curve multiplication function. So this function generates the public key from private key. This no need to be secret. Account address is generated from public key, and public key is used to verify the digital signature. This is an example of public key. So I have mentioned this elliptic curve multiplication. So now I need to explain what is this elliptic curve. So in 1985, both Koblitz and Miller independently suggested the use of elliptic curves in the development of a new type of public key cipher. An elliptic curve is an elliptic curve equation is of the form y squared equal x cubed plus ax plus b, where a and b is in finite field of characteristic p not equal to 2 or 3, and in the form of y squared plus xy equal x cubed plus ax squared plus b for f of characteristic 2. So this is an example of an elliptic curve over real numbers. So this elliptic curve has equation y squared equal x cubed minus x. This is another example of elliptic curve. Y squared equal x cubed minus half x plus half. And another example, y squared equal x cubed minus 4 over 3x plus 16 over 27. But the elliptic curve that we use for cryptography is an elliptic curve over finite field. For example, here over GF23 or Z23. The equation is as before, y squared equal x cubed plus ax plus b. In this example, y squared equal x cubed plus x plus 1. But then, since we work on this finite field, so the curve looks like a collection of points. So we can call it like a discrete curve, not continuous. And So this point satisfy this equation, and although this doesn't look like a curve, but we still call it elliptic curve. So the importance of using this elliptic curve is because we can define elliptic curve addition. Here, how to define it? So for example, if we have this point P and this point Q both on the elliptic curve, we make a line that join P and Q, and then we find the third point here, and then we reflect over the x-axis, and this point we define it as P plus Q. And we can also find the point P plus P or 2P, and this is done by drawing a tangent line to P and reflecting the point at which it intercepts the curve. So here, if we have this point P, and then we make this tangent line, we find the second point, and then we reflect. So this point will be the point P plus P or 2P. And if you want to compute 3P, 3P is easy, it's P plus 2P. So now we have previously P is here, 2P is here. How to get 3P? From P and 2P, you join with this line, and then you get the third point, you reflect, you get 3P. And we can continue to compute 4P, 5P, 6P, and so on. And by using this addition operation, so this point in this elliptic curve can form a group. And so if we go back to the digital signature, to send money, user must prove that he is the owner of the address. To do that, user generate digital signature. And nodes in the network can verify using this signature that he is the owner of the account, and then he can spend money. And Bitcoin digital signature use elliptic curve digital signature algorithm, or ECDSA. So the signature generation as parameter a prime number P, an elliptic curve P, a point P of order n. This order means the smallest positive integer such that n times P equal O, where O is the identity of the group of elliptic curve. And then the private key D between 1 until n minus 1, and also plain text M. For signing a message M by Alice, using Alice private key DA, and as the public key is this point QA, where this is a number DA between 1 until n minus 1 times P. So in my example, previous example, we only see 3P, but this DA can be 5P, 100P, and so on. And then we calculate the hash of M, where hash is a cryptographic hash function. We select a random integer k from 1 until n minus 1. And then we calculate this R x1 n. X1 is...
Excuse me, ma'am. Ma'am,
yes?
Please once again represent your screen, ma'am. Somebody else has presented the screen. Please represent it. Present your screen again. Present your screen again.
Okay.
Yeah.
Okay, let me try again.
Participants, please don't share your screen. Don't present your screen.
Can you see it now?
Yeah, ma'am, yeah. Yeah, now.
Okay. 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 So I repeat, this is the signature generation. We calculate the E as the hash of M. And then we select an integer k from 1 to n minus 1. And then we compute this point k times p. And from this point k times p, we have this coordinate x1, y1, where we compute the r, which is x1 modulo n. N was the order of this point p. When r is 0, we go back to step 2. But when r is not 0, we compute this as k inverse. K was this integer that we choose here. And then E is the hash of M plus this number D times R mod N. But if we get S equals 0, we go to the step 2 again, means we have to choose another K. And the signature is the pair R and S that we send. And then for the verification, for both to authenticate the Alice signature, both must have Alice public key UA. To verify that R and S are integer, first verify that R and S are integers from 1 to n minus 1. If not, the signature is invalid. Calculate the E hash of M again, and calculate W as inverse mod N, and then calculate U1 EW mod N and U2 RW mod N, and then calculate X1 Y1, which is U1 times P plus U2 times Q. So the signature is valid when you get X1 equal to R mod N, and invalid otherwise. But here I want to show that the domain parameter that used for the ECDSA in Bitcoin, the curve that is used is called the Koblitz curve SECP 256K1 that are specified by this sextuple P, A, B, P, and N, where P is the prime number and the finite field FP is defined by this prime number P. Okay, let us just believe that this is a prime number. And then the curve that we use is the curve E with this equation y square equal x cubed plus 7. And then the base point P, this is written in hexadecimal. And the order N of P is also here written in hexadecimal. So you can see that we use quite huge finite field here with a very big P here. And then the Bitcoin address is strings of digits and characters, and then generated from public key. Share with anyone who wants to send you Bitcoins, and user can have many addresses. So this is, for example. So as we seen earlier, so from a private key, there is an elliptic curve multiplication one way here to get public key. And then there is a one-way hash function to get this Bitcoin address. This public key generation is by using elliptic curve, and address generation is by using hash. And the advantage of elliptic curve is that the shorter keys are as strong as long key for RSA, low on CPU consumption, and low on memory usage. RSA relies on the hardness of factorization, while elliptic curve depend on discrete logarithm. Discrete logarithm means that when you know public key, then how to get the private key. in simple is like that. So this Bitcoin is collective entries into a ledger, and every transaction ever happened recorded on one global ledger. To send money from Alice to Bob, account has to have enough money. To verify money in the account, we need to verify previous transaction. When Alice has 5 Bitcoins, means someone sent Alice 5 Bitcoins before. So input should be 5 BTC and output cannot exceed 5 BTC. No record of account balance are kept. Instead of balance, fund is verified through link to previous transaction. Input should match the balance. So here, for example, so Fred has sent Alice 2 BTC before, and Charles has sent Alice 3 BTCs before. So then Alice now have 5 BTCs that she can send it to Bob. And transactions are not encrypted, so it is possible to browse and view in this. You can see this is address and public key. And this is input balance should match. This is the input and this is the output. So this is the transaction example. And there is also each transaction here includes its previous transaction. So between this B address and B public key must match. And when we have transaction to B to C and then transaction from C to D, this C's address should match with C's public key. And A use his private key to sign, and then public keys to verify, and also B's private key to sign and B's public key to verify, and so on. When you install Bitcoin wallet, it downloads every transaction and checks each one's validity all the way back to the first transaction ever made. And blockchain, the public ledger, is used to order transaction. One block of blockchain includes many transactions that considered to have happened at the same time. So, and computer or miner collects unconfirmed transaction into a block, broadcast the block to all nodes, like this. And we can think of global ledger is the book. One block is the page of that book, multiple transactions listed in that page, and miner's goal is to take this page and add to the global ledger book. So for the potential outcome of BTC, it will either succeed with the mainstream or fail. If succeed, by 2025, it's estimated world GDP is expected to be around $71 trillion in the year of 2025. But it's still experimental, so its future cannot be predicted by anyone. And theoretical and technical problems which goes against favor of Bitcoin usage, illegal activities, theoretical base for digital currency usage, regulation and taxation issues, disputable status of independent and decentralized currency, mining problems, skepticism toward implementation of new unregulated in finance sphere. So we can see here legality of Bitcoin by country. The green one permissive, yellow contentious, red hostile, and black one are unknown. So this advantage, it is easy to set up and it is fast, low and irreversible transaction fees without central authority, but this could be also a possible disadvantage. And for the disadvantage, new and uninvestigated financial products, history is full of illegal and questionable activity, absence of relevant theoretical background, undefined legal status, and unregulated commodity and absence of consumer protection, anonymity and blurry taxation status. Illegal or undefined in most countries of the world. So these are the sources that I use for these slides. And thank you very much for your attention.
Any questions, any doubts? If you have, you can just ask, unmute yourself, and you can ask the resource person. Participants can ask questions. This is the question section.
Hello.
Hello.
This is Radhakrishnan. Hello.
Okay. Hello. Nice to
Fuzzy
meet
cryptography.
you. Pardon?
Fuzzy cryptography.
Fuzzy, not really. So this is more using elliptic curve.
Okay.
So this has some interest on. I'm interested on this because of these points in elliptic curve can form a group. I mean algebraic way, and then in that group we can define addition operation, and then we can work like we have group, we can define the cyclic group and so on. But if you mean by fuzzy and then related to fuzzy algebra means you will have maybe other operation.
Oh. Thank you.
You're welcome.
Hello.
Hello.
Ma'am, for digital signature, are they applying only elliptic curve cryptography method or any other method? RSA digital signature.
Digital signature usually used for cryptography. I don't know if they are used in other way. Well, basically, like right now, for example, when you work online, you work from home, and then you need to sign a very important document, and then but then if you just put your signature in your PDF and then someone can steal your signature, that's why I think this digital signature is very important, especially nowadays. But if it is used not for cryptography, I don't know. But anyway, I mean, this is a very important issues right now, since now someone can easily steal our signature because we cannot sign it. We cannot come to the office and then sign it properly. Is that answer your question?
No, my question is, you are telling to apply that elliptic curve crypto digital signature. Can we use RSA digital signature for this? Globally, what they are using for Bitcoin, what signature they are, what methodology they are using for digital signature?
As far as I know, that in Bitcoin we use this elliptic curve digital signature algorithm. I don't know if we can use other digital signature. But like I said before, the advantage of elliptic curve is that we can have shorter keys with the same security.
I think the elliptical digital signature is more powerful than RSA. I think. I don't know. I heard it long back. It's a more powerful when compared to RSA.
Okay.
Yeah, it's, but still, we also face a problem that
Finding the curves, it will be difficult. No, for elliptic curve, finding the curves.
Yes.
Yeah, yes, it's become more difficult than to hack than the RSA, because for example, if you have this Q equal K times P, and then how to get the K where you can see that the operation addition is not that easy. It's using this geometric, you find a line joining 2 points and then you reflect and so on. But still, there is a doubt about this elliptic curve cryptography nowadays. Like some say that when this quantum computer arrive, and then this discrete logarithm problem will be easily solved, but that's theoretically. So nowadays, people are trying to use cryptography that more secure, which is not based on discrete logarithm problem. But anyway, for now, I think this ECDSA should be okay.
Okay, thank you.
Yeah, I see there is a question. If you lost your private key, yes, someone can use, and then can. I mean, in our story here related to Bitcoin, this private key is used to say that it's me, Alice, that verify to sign, and then, but if someone else stole your private key, and then you can pretend that you're Alice, and then like you're spending Alice money, and then you can sort of lose your money because your private key is stolen. Okay, let me see again if there is another question in this chat. Okay, I don't see any other question.
Madam, what is the difference?
Yes.
What is the difference between private key and foreign key? Is there any role for foreign key in this Bitcoin transaction?
What do you mean by foreign key? What I know and what I have been explained was there is private key and public key. Private key only Alice know, but for public key, anyone else can know that. And this public key is known by many others and can be used to verify the transaction. Like I said before, it's like the public key is like your email address. Anyone can know. Even in the first slide, I have shown you my email address, but the private key is like the password for my email. Only me who knows it, and only me who can use my that address. I don't know if that answer your question.
Okay. So it is possible to use 2 digital signatures for a single transaction?
I don't know. I don't think so, because I think I have mentioned earlier that this Bitcoin transaction is can prevent the double spending. So if Alice use one private key to sign, and then when someone pretend to be Alice and then sign again, and then in the blockchain, in the ledger, we can know that there is a history that Alice has signed before, and now why there is another signature of Alice. So I don't think we can use two signature for one transaction.
Thank you,
Okay,
ma'am.
you're welcome. Why particularly choose elliptic curve? So I guess because in the form of the equation y square equal x cube plus ax plus b, first the y square gives us two points, for example xy and x minus y, and that's allow us to reflect along the x-axis, and then the formulation of x cube allow us, as you know, if we have x cube and then we can have 3 roots, and based on these 3 roots, and then we can have like the third point with so you have this point P, and then you have this point Q, you have this line joining P and Q, and then you will have the third point, and this existence of the third point is based on this x cube. I think that's the reason why elliptic curve then can be used here. So basically, it's just because you can sort of define addition operation on that set of points in that elliptic curve, and then well, I should also mention that being a group means it should have an identity element, but the identity element is not on that curve. It's in this it's called the point of infinity, the point that I call it point O, but I try not to explain that too much in detail, because today what I want is to show that in this cryptocurrency that quite powerful nowadays, there is a beautiful algebraic object inside, and algebraic operation that that maybe only mathematician who can appreciate that.
Yeah, if there are no questions, then I'd like to give some instructions. That is, tomorrow our session will be from 11 to 12, and I'd like to thank Dr. Intan for accepting the invitation. The presentation is really good and very informative, ma'am. We learned here what is cryptocurrency and Bitcoin. Being a mathematicians, we are not that much clear or familiar with Bitcoin and cryptocurrency. Now we are very much clear about the concept. And you clearly interrupted how mathematics is applied in digital currencies. And also the advantages of elliptic curve, advantages and disadvantages of Bitcoin and all. So we are very much happy that we are here for this session. And also I thank Professor Said Brownie for attending this session in his busy schedule. Actually, I asked him for giving a talk. Due to his busy schedule, he couldn't able to give the talk, but he attended now. So I am very happy for him too. Thank you, Professor, and thank you, ma'am. And also I thank participants for their patience attending. Thank you.
Okay, thank you very much, everyone.
Yeah, thank you, ma'am. Tomorrow's session will be from 11 to 12. Participants, please note that. Thank you.
Thank you, ma'am.
Okay, may I leave now?
Yeah, ma'am, you can. Yeah, ma'am, you can leave, ma'am. Thank you so much.
Okay, thank you very much once again.
Thank you, ma'am.
Yeah, thank you, ma'am.
Thank you, ma'am.
Thank you so much, participants. You can fill the feedback form which is given in the chat box for today's attendance.
Thank you, ma'am.
Please fill the feedback form which is given in the chat box.
Thank you for the feedback.
Yeah, it is open, ma'am. You can fill. Yeah, we'll send it again. Paste பண்ணிடுறேன்.
Sachne, அமைதியா இரு.
Could you share the link again? The feedback link?
Yeah, sure, ma'am. You can see in the chat box.
Okay, thank you.
Yeah, thank you, participants.